Well, good afternoon, everyone, and welcome to today's, even this afternoon's Global Built Environment Congress here at the British Standards Institution, where this afternoon we are talking all about cyber physical infrastructure. My name is Dan Rossiter. I am one of the built environment sector leads here at BSI. And before we get to our various sessions and presentations and showcases, I just want to take us through a quick bit of housekeeping before all the interesting content can begin. The first thing I'll let you know is that today is a listen-only webinar. What that means is you won't be able to unmute yourselves and you won't be able to turn your camera on as I have now. But what you will be able to do is interact with us, and we'd really like you to interact. The way that you can do that is by using the questions panel on the side of your screen. If you look on the right-hand side, you'll see the user interface where you'll be able to post your questions. Now, as part of this, you can use your questions to do two things. The first is if you're listening to the presentation and you're, oh, that's a very interesting thing, I want to ask a question about that, then you can submit a content/technical based question via the Q&A. And what we'll do then is at the end of sessions, time permitting, we will go through those questions and do a Q&A session with presenters. If due to timings we're unable to do so, we will ensure your questions are passed on afterwards, and we'll form a brief Q&A summary sheet at the end, which we'll post with the presentations afterwards. At the same time, if you have any issues with your session, say for example the audio keeps cutting out, what you could do is post that in the Q&A session, and some of our team behind the scenes will respond and try their best to help you. Normally, questions will be asked about access to slides and access to recordings of the webinar. So to confirm at the start, after the webinar has been completed, you'll receive an email with the option to do a feedback survey. Completing the feedback survey will give you access to the link to the recording of the webinar once it's been edited and uploaded. And as this is a CPD recognized webinar, this is also the same mechanism where you can request your certificate. So hopefully there are some very good useful bits that you can pull out of that. The main one being, use the Q&A function. We'd like your questions. Please ask them frequently and often, and we will get to answering as many as we can this afternoon. And without further ado, that's probably all you need to hear from me. So what I'm going to do is pass over to Jacob, the digital twin lead at Bayes, who's going to talk to us a bit about cyber physical infrastructure and the work they have been doing there. So Jacob, I think over to you.
Great, thanks very much, Dan. And hi all, thanks all for joining. Great to have such a big crowd here. Yeah, so I'm going to give a little bit of an intro to what we mean by cyber physical infrastructure when we talk about it and what we've been up to in government. I will turn my camera off in a second so you can focus on the slides. I have had a sneak peek of the slides from the other panelists, and I assure you they get increasingly pretty as we go. So bear with me on the slightly government style slides, and it all gets better from here. And without further ado, I'll knock my camera off so we can focus on that. But really, cyber physical infrastructure, it's one of those terms in the emerging tech space. What do we mean when we say it? It's a helpful place to start is with cyber physical systems themselves. So systems that connect the physical and digital domains. We're increasingly familiar with them, things like digital twins, robotics and autonomous systems, augmented and virtual reality. These systems provide a link and a mechanism for delivering value through connecting the physical and the digital domain, whether that's increasing understanding, whether that's actioning between the domains. They're becoming increasingly prevalent, and the benefits of those individual systems are becoming increasingly demonstrated. Where we are particularly interested is where those systems start to come together. So the value of those individual systems increasing as you begin to connect them to form systems of systems. A useful analogy is the internet. So an individual end user device, a computer, a mobile phone, wonderful. You can play fun games, you can do really good maths on them. But the additional value you get when you connect those into a network like the internet is far above and beyond what the individual systems can deliver themselves. We're familiar with the internet as an infrastructure in both our kind of daily personal and professional lives. We build services, we deliver services, we innovate, we collaborate. And that's really the vision we're looking at, moving from a kind of digital network system to the cyber physical. So that's why we talk about cyber physical infrastructure. The infrastructure sitting across the cyber physical that will enable this range of innovation, collaboration, and cooperation. This is a diagram to bring a little bit of it to life. And the two really key things here on this diagram are showing, one, the interconnection of our physical world as we know it. Our physical systems don't exist in isolation, they're systems of systems. And then flowing from that, the interconnection of our cyber physical systems that would have to result. So some examples as we go around of the kinds of areas where cyber physical infrastructure could bring real benefit to the UK and globally. Innovative product development, design, manufacturing. We're already seeing, for example, with manufacturers, how they're using cyber physical systems to model, optimize, and operate their development facilities, their operational production lines, allowing collaboration across different geographic regions, using augmented and virtual reality, as well as synthetic environments. Once you get to the front door of those warehouses and factories, the advanced transport and supply chain, so everything from kind of the individual components, individual drones, connected to autonomous vehicles, through to how you connect between different nodes of a supply chain, how you optimize across the supply chain, how you build resilience in there, greater visibility. And again, we're talking here about federated systems, not one mega system that owns it all, but how different users and developers who have their own systems, their own purposes, can start to connect those and share those with partners for greater value. Energy systems are a massive area. We're moving from kind of large central distributions through to very disaggregated and highly variable systems, where we'll have lots of small producers of energy, and we'll also have very variable input. So how do we optimize and ensure the resilience of that really complex problem, from offshore wind, small solar, highly variable due to weather inputs? How do you bring that all the way through to managing dynamic pricing with consumers and managing some of the energy challenges we're seeing coming up this winter, for example? Agriculture is another example, right through from kind of the operations, the drones, the autonomous equipment, through to land management and the natural environment. And then similarly, the connected public sector is a real opportunity here for how government operates, how policy is made, how interventions are designed and monitored, right through to how we deliver frontline services through healthcare, prisons, benefits. And I think you can see across all of that from the graphic, the built environment element of that. The built environment cuts across pretty much all of this. So there's a real kind of opportunity in here to act in each of these spaces, and then I think we'll come on a little bit shortly after to the kind of net zero element as well. Why should we care? And I say I use we there kind of both for we as a collective, but also we as a government. What's the role of government in this, working with industry and academia and wider society? There's a real opportunity for the UK here to maximise the leadership for the UK and really benefit things, areas we're already really good in. So the UK being a testbed for innovation, the opportunity here to enable cheap, quick and effective innovation through increasing the ability to bring together digitalized and physical test and iteration, along with that collaboration piece across different domains. Real opportunities to exploit some technology areas we're really strong in already, so AI and robotics, and also thinking about the coming metaverse. And there's also, as we kind of covered with the previous slide, a lot of opportunities within sectors we already have great strength in, so built environment, manufacturing, energy, transport and logistics. And I think that's the point that I trailed earlier, was there's a big net zero theme across all of this. So there's some kind of really critical use cases in this space. So future energy generation, our future nuclear power plants aren't going to have humans in them. They're going to be large, highly sensorized buildings operating with autonomous systems inside, doing all the monitoring, the safety, the operations, responding to crises. How all of that ties together is absolutely this, how you start to connect those different robotic, autonomous systems, sensors, synthetic environments, digital twins of the infrastructure. Energy systems themselves, like I talked about, how we manage our future energy grid, and then really sector transformation across each of those sectors. There's a real push, a massive transformation needed both in how we operate and the underpinning technology of each of those sectors, and both enabling the testing and innovation of will this change in how we operate work and how do we do it effectively, but also embedding lower carbon ways of operating in. There's a real opportunity with cyber physical infrastructure to help enable that. And I think the kind of flip side of the coin is this is all exciting and good stuff to be doing, but also it's going to happen. And this is where we really come to that kind of government point of why does government need to care. A couple of things that came through really strongly in engagement we've been doing is around security. We've seen with, for example, telecoms, when it's kind of some of these things are left to organically develop, they develop in ways that aren't necessarily sustainable from a country that needs to be secure and resilient. So we saw with the high risk vendors work that happened in telecommunications. A number of vendors, including ZTE and Huawei, were subsequently removed from the telecommunications infrastructure, which obviously comes with disruption, cost, etc. So how do we get ahead of that risk developing in this environment? And then also innovative and competitive markets. We've seen with the development of the web how particularly digital systems are prone to consolidation, which can lead to having very large kind of gatekeeper organizations owning large amounts of business or data, and that doesn't necessarily give an optimal innovative outcome for society and consumers. So again, how do we think about the risks emerging in that space? Some of you may well be aware we ran a consultation on this earlier this year. Thank you all of you who engaged. We got a fantastic level of response. The consultation itself was really about three things. It was about putting out the kind of the shop stall in terms of what are cyber physical systems and what are the opportunities and what can the UK do in that space, and then taking it up that level that we've gone through these slides of how do those come together into a cyber physical infrastructure, what are the opportunities there, what are the barriers, and what do we do about them. It was a very early stage consultation. It was really about kind of setting out what is an emerging picture and getting some validation on that. We got a really fantastic level of response. We got a large range of businesses, wider public sector, academics, charities, wider society, organizations engaging with it. We got a lot of large major tech providers providing written responses. We also did a large number of roundtables. I think we did 15 in the end. And we got a lot of SMEs attending those as well. So a really high level of positive engagement. What was the kind of, we're working on the consultation response and we hope to have it out in the new year. So I won't prejudice what's going to come out in there, but as kind of a initial, flavor of it, we got a very strong endorsement of what we've just been through in terms of the opportunities and the challenges. We also got a really strong endorsement of the role of government in tackling some of those systematic challenges. So particularly systematic challenges, I won't read them on the right hand side, but you can see those there. Those are the themes from our consultation. Particularly security and interoperability came through time and time again from stakeholders about how we develop systems that are secure and people can trust them, and how do we enable interoperability, both from that kind of markets perspective, but even more widely from a kind of how do you scale this, how do you make it cost effective for people to engage with, and that's both from a technical and a non-technical perspective. So strong endorsement of the value proposition, strong endorsement of the role of government, and now what we're doing is working through the number of, a wide range of partners, including all those who responded to the consultation, to take this work forward. So I know there are a number of you on the call, and I know we've got some people coming up shortly to speak as well. So won't keep anything more your time on the scene setting, but just say a big thank you. And this is very much kind of the kicking off of the work for us. So we look forward to publishing the consultation in the new year, and then commencing the kind of getting into the delivery of this. I will hand back to Dan.
No, that is brilliant, Jacob. Thank you for that. And we've gotten a couple of questions through on there, which is excellent. And as I said at the start, keep your questions coming. I'll start with what might be quite an easy one. It's from Dr. Taylor. He's asking about the source and provenance of the diagram you've shown about the applications of cyber physical systems, because to be honest, I quite like that diagram as well. And I guess the question really is, who made it, and where can they get a copy if they wanted to refer to it?
It's open source. We commissioned it. It was produced by a lovely graphics team over at Ministry of Justice. It's in our consultation. So can I post a link in the chat, Dan? Or I can say you can.
if you post a link to the chat,
We'll go through.
which goes to
Yeah,
the organizer and panelists,
cool.
our team will share it with the attendees. And I'll, by saying that now, it means they'll have to do it because I've said it out loud.
Perfect.
So
That's
that'll
fine.
happen.
That sounds like someone's been set up to ask the question, because it will give us a chance to put a link to the consultation in the chat. So yeah, it's in there. Feel free to copy, paste, share with all your friends and family.
Well, excellent. And then that's the first one. Second one, I think in it's something that spoke to me a little bit because Tristan's mentioned about, we've talked about a few times, you mentioned things like healthcare, agriculture, and some other bits and pieces. And given, we're talking about the built environment today, and some of those don't traditionally fit under there, can you touched on it a little, but can you emphasize that relationship that built environment maybe has into those other areas that people might not have really connected the two together?
Absolutely. I think some of our panelists who are more specialists in this area will do it more justice than me. But I think what we hear from stakeholders time and time again is, particularly as we move into this world, like digital twins are the example that gets talked about most in this space. This is moving buildings from kind of static assets into dynamic assets that need to interact with the things around them, whether that's kind of your facilities management, your heating, your operation, through to the robots that are going to be navigating these buildings, through to what understanding the kind of the full circular economy of these assets, how you design, build, operate, and then reuse, decommission. So it's absolutely critical. This is a critical underpinning to how you actually enable that change in use of the built environment. And I mean, the built environment expands right out from kind of individual buildings through to the wider range of built infrastructure we have, which kind of are probably some things like we talk about rail, energy networks are kind of potentially considered already more kind of, a lot of people have them in a more dynamic framing in their mind, but solid physical infrastructure will underpin both the connection and the increasing dynamism of the operation of those. So it wasn't called out explicitly in that diagram, but probably because it is so cross-cutting across all of them.
Oh, that's really helpful. Thank you. And I think that I have a few of my own questions, but I think they'll have to wait probably because of our timings for today. So what I'll say is thank you for joining us, Jacob. That's really helpful. I hope those of you who are watching click on the link that's been provided in the chat and do have a look at the consultation documents. I think we'll all just listen out then for the results of that going forwards. And interestingly, in no way of creating a segue, you did talk about digital twins there. So I think that what that does is it hopefully tees up the next part of today's program, which is to have Alex Luck come join us and speak about the National Digital Twin Programme. So Alex is joint policy lead for the programme itself at BEIS, and I think, Alex, as you've popped on screen and come to say hello, I will hand over to you.
Lovely, thank you very much indeed. So, seem to have jumped. Right, okay. Right, so just really to start off, just want to talk a little bit about what is a digital twin. Now, I don't want to get too hung up on this because, and I'll just turn my camera off. I'll turn my camera off. Right, so don't want to get too hung up on what we actually mean by digital twin, because I think there are multiple definitions out there, and that's actually probably coming up with one single definition probably isn't the most important thing we need to do. But however, what we do talk about in BEIS is we talk about digital models, digital shadows, and digital twins. So we have the most basic, the digital model. You have a digital model, and that doesn't necessarily need to be a 3D model, but we have that digital model of a physical asset, system, or process. But any change in the physical environment, if that is going to be reflected in the digital environment, needs to basically be a manual process of updating the digital environment. When we talk about a digital shadow, we talk about sensors, technology being embedded within the physical environment, and that technology feeding information back into the digital space. So changes in the physical environment can be automatically updated in the digital one. And when we move into the space of digital twin, we talk about that flow of information being two-way. So flow of information from the physical into the digital, and from the digital back into the physical environment. And that flow of information doesn't need to be real-time flow of information. It just actually needs to be right time. So what is right for the use that you are putting, how critical is it that that information arrives at particular times? But as I said, we've got multiple definitions of digital twin out there. Will we ever get to the point where everybody agrees? Probably not. So the main thing really is that the user is able to specify the functionality that they require, rather than using those terms which very often mean different things to different people and therefore can cause confusion. Supply chain won't deliver one thing, the user then is dissatisfied potentially because it doesn't meet their requirements or their expectation. So a real focus around, as I say, that functionality. Now my slides won't move. Sorry, right. Okay, seems to be a bit of a lag on that. So while we talk about a digital twin of an individual asset, actually, you do tend to end up with a far more complex picture than that. So it will be made up of any single asset. You will be made up of elements that you could consider to be digital model. So in other words, the digital and the physical are not connected in any way because there's potentially no point in that connection existing. We'll have other elements where there will be sensors embedded in the asset that are feeding back on the condition potentially of different aspects of that asset. And we'll have other elements where there will be real value in having the two elements twinned, so the physical and the digital element twinned. And that picture becomes even more complex when you move away from individual assets to where you have multiple assets owned by a single organization, and even more complex when you move into that space of having multiple organizations owning multiple assets in a broader ecosystem. And of course, as well as that, digital twin is not a single technology. In order to create digital twins, we are going to need to bring together multiple different technologies in different sorts of combinations to achieve particular outcomes. So we talk about sensors, we talk about high performance computing, robotics, 5G, complex modeling and synthetic environments, AI, machine learning, flow of information. All of these different things we will need to bring together in different combinations to meet user demand depending on the particular use case that we're talking about. So we really need to understand what do all these different aspects do and when do they drive real value in using them and bringing them together. So not just using technology for technology's sake, but ensuring that whenever we do something, we don't end up spending more on the tech than the value that we get back. We also tend to focus on the highly visual aspects of digital twins. We get quite caught up in that, in the big vision of what digital twins will do, the benefits that they're going to be able to bring for us. But of course, there are actually hugely complex issues that we're going to have to grapple with if we're going to be able to deliver this vision about being able to ultimately bring individual digital twins together into ecosystems of connected digital twins. So we don't think, given looking at how much there is that we're going to have to think about and resolve, we don't think that if we are going to be able to deliver trusted, ethical, secure, safe and resilient digital twins, this is something that is going to be just around the corner. I think there's a lot that we're going to have to really, as I said, grapple with to get right, so that actually we don't really have to worry so much about, the end user doesn't have to worry so much about all of that stuff that's under the surface. They can focus on that real interface with the digital twin and trust that all of those particular aspects have been taken care of. In the same way that we use a lot of technology these days, we don't necessarily understand how it all works, but we know it performs in a certain way, that it delivers in a certain way. And that's probably where we really need to get to with this type of this sort of combination of technologies. And that really is why government is funding the National Digital Twin, and why it's funding other work in this digital twin aspect, is actually looking at these really tough problems underneath that are going to deliver this trusted, secure, safe, ethical and resilient digital twins. Because if we're going to use these things for public good, we know that all of those underpinnings have to be there. So what is the National Digital Twin Programme? Well, you'll probably be familiar with the fact it used to be based at the Centre for Digital Built Britain at the University of Cambridge. CDBB closed at the end of March 2022, and the decision was made to bring the National Digital Twin Programme back into the Department for Business, Energy and Industrial Strategy, BEIS, to run the programme directly out of the department, which is quite unusual. The programme acts as a focal point to grow national capability in digital twinning. And while it is being run out of the department, we are still working very closely with industry and with academia to really create the rules of the road that will enable us to build digital twins, that I said, that are trusted, that are ethical, safe, secure, and resilient. So very much focused on not creating the digital twins themselves, but creating those rules of the road. And equally, those rules of the road will not only enable those digital twins to perform in that way individually, but also to be able to start bringing those digital twins together, but to ensure that all of those really key fundamental requirements are maintained when we do that. We're also working really closely with colleagues across government, so both within the department, and you heard Jacob speak just before me, Barry and myself, who are the joint policy leads of the National Digital Twin Programme, work really closely with Jacob and his team, and they've been hugely supportive and helpful with the work that we're doing. We also work very closely with other departments across government. I know, joined up government, bit of a novelty, but we do very much focus around making sure that we do have that link up across government, and that we do talk to colleagues and we share what each of us is doing and share knowledge, and I always say steal with pride as well on that. We also work extremely closely with our colleagues at UKRI, who are doing some fantastic work in the digital twinning space as well. And this is all about really trying to drive that value for money and ensuring that we're not duplicating effort, and we can move as fast and as possible within this space and really drive the benefit forward. And ultimately, what this idea about being able to bring these digital twins together will enable is to take an array of information from multiple sources, to be able to then visualize it, to be able to interrogate it. We can start simulating scenarios, and then we can use that to be able to optimize systems, assets, and processes in order to really start driving public good. So that's really the government interest in the programme. And ultimately, that means that we can start to create this ecosystem of multi-domain, multi-sectorial digital twins that will be connected via this securely shared interoperable information of a known quality, so underpinned by this information sharing. And that's something that underpins all of these cyber physical systems, is that ability to start shifting information between systems in a secure and interoperable way. What we're not doing is creating the mother of all digital twins. So while we talk about a national digital twin, we don't mean that we're going to create an almighty digital twin of everything within the UK. And it's certainly not about connecting everything to everything else within that space. This is about being able to assemble information and digital twins from particular use cases together. Some of those digital twins will only need to exist for a fairly short amount of time. So if I've assembled various digital twins and information in order to make a particular decision, I might then want to be able to discard that. I might not want to be able to retain, I might not need to retain that digital twin. But actually in other use cases, it would potentially be very useful to retain that digital twin and to be able to scenario plan with it. So I think, again, it's important that what we're talking about is people being able to connect digital twins and information that are fit for the purpose to which they want to be able to put them. So they're not getting more than they need nor less than they need. So rather than looking at one solution fits all, it's about users being able to get the solution that meets their needs. As I say, we've got a long way to go to be able to do this. I said earlier, you know, I don't think we are, these types of things are just around the corner, and this ecosystem of connected digital twins are some way off in reality. So I think we really need to be very honest about where we are, what capability we have at the moment, and just how much we're going to have to sort out and to crack to be able to get to the end goal. Now, that doesn't mean that there aren't going to be significant benefits along the way, because there clearly will be, and there will be huge value that we can really start driving during the course of the programme, and being able to increase people's capability in this area and creating those rules of the road that will allow others to really take those rules of the road and drive this forward as well. And nor is there going to be one set way of doing it. Well, I mean, this diagram, it just shows a path up to the summit. But in reality, there are multiple paths that you could take. And we're going to have to be quite agile about the way that we do this. We will find things that work, things that don't work. We'll need to reflect on what we are learning as we go along. We will probably need to pivot and adapt regularly to ensure that we are still driving towards where we need to be. But as we pick up challenges along the way, and as we identify problems that will need to be solved, we're going to have to think about how we do that and how that maybe changes priorities about what we're doing and when. But if I wanted to break the program down, I think, you know, it's clearly, it's in government terms, it's not a huge program, but it's still quite a large program. And it's obviously very complex. There's lots of elements to it that we need to pick up. But I think in simple terms, we can probably break the program down into three key areas. So the first one is really around developing the standards, the guidance, the processes and the tools that will enable people to gather, process, manage, store and share information. So this is around us ensuring that we can get the right information to the right people at the right time, and that the users understand the quality of the information so that they can decide whether that information is fit for the purpose to which they want to be able to put it. We've got to ensure that this ability to share information is part of a compelling business case. So there's got to be real justification for why people, and business reasons for why people would want to participate in something like the National Digital Twin. So they've got to be able to understand the value, what they are going to get out of it. And quite frankly as well, what it's going to cost them to participate. What do they need to do in order to be able to share their information and to be able to get access to other people's information that is appropriate that they should have access to. So what we're looking at really is how can we offset that cost of and the amount of effort that's required for organisations to implement what's going to be required to be able to participate, and look at that compared to what value they're going to be able to drive from it, as well as obviously from a public sector benefit. What is the public good that we get by enabling this information sharing with organisations that are providing public service? And the work this year in the information management space has been very much focused on the development of the integration architecture. So what we're talking about very much is how can we facilitate organisations to take the information from the systems that that information currently sits in and move it into a space where we can get it to the state that it will enable that interoperable information, and that information ultimately then, when the organisation chooses with the appropriate security controls, to be shared with others that they wish to share it with. The expression that the technical team that developing this use, which I really like actually, is about taking people's brownfield data into a greenfield site and being able to do things with it. So we're not turning to an organisation and saying, if you want to participate in this space, you've just got to change everything that you're doing and all the systems that you're doing it in. We've got to be able to leave information in people's existing systems and look at what we can take from that and how we can, as I say, therefore make it interoperable. So the integration architecture, it's been developed. So it's something that's called Core is the platform that is being built. Core will be open source. We will be releasing. We'll get to the stage of some of it being open source at the end of this financial year. But what it does, as I said, is it takes information from existing systems that is probably siloed and takes it into a process that allows us to, or allows the organisation to standardise and unify that information in a secure environment, but an environment in which the user can then start to really exploit that information far better. The core is being built so that it is zero trust, and it also will have attribute-based access controls, or actually already does have attribute-based access control within that. So that allows the user to apply really fine-grained security right down to individual attributes about who can see what and when. So as I say, the information flows from the client's different systems and from other data feeds as well that the organisation wishes to use. The data comes into Core, it is then cleansed, it's resolved against existing information that's held to remove duplication, and then the information is mapped onto the 4D ontology that we are using. And the one that we're currently using in this development is the Information Exchange Standard 4. That's something that was developed primarily by the defence and security community, but we are looking at how we can extend that so that it applies across the built environment as well. A huge amount of work going on looking at that ontology and what we have to do to it to get it fit for purpose, for our purpose. Information is then, once that all of that cleansing and resolution and mapping processes happen, the information is then mapped into these smart caches, which again, the attribute-based access control is secured in those smart caches as well. So effectively, the core takes care of all those really tricky problems around those sort of high friction areas that we always come up against when we try and be able to share information. So all of those controls and those aspects and ultimately the sort of legal and commercial arrangements that will need to be in place will be built into that so that people can then use that to share information as they choose to. And then other organizations can then come in, they can start sitting applications on top and really allowing organizations to innovate in this space and to look at what additional benefit we get by having that standardized information underneath where all of that security is taken care of. The integration architecture is going to be a distributed system, so each stakeholder will own their own node, and then they will be able to share information across different nodes, so between different organizations as you know, they're obliged to do in the case that there's a requirement they have to share information, or where it suits their organizational need. And ultimately, what we'll also need to have is a management node that manages who's got nodes, how we monitor the health of the whole system, cataloging the data that exists that people can share or get access to, and there'll be layers around how that works as well. But it will also control the data standards, pushing out improvements to IES4, etc., or the ontology that we end up using, as well as looking at updating and controlling the master and reference data that's used within that system. I would say we certainly haven't built all of that at the moment, but everything that we are doing, absolutely no smoke and mirrors around it. We'll be very honest about exactly where we've got at this stage. And just again, as I say, how much work we've got to do to be able to get all of that I've just discussed to be a reality. The second stream of the program is then about saying, once we've got that standardized information, what is it the users need to be able to engage with that information, visualize it, interrogate it in a way that meets their needs and enables them to make the decisions they need to make. Now, some of this may be very simple visualization tools all the way up to digital twin. But again, it's about understanding every time we add complexity in terms of the tools that we're using, what is the additional value that we get back from that? So again, ensuring that people don't spend more in the technology than the benefit that they get back from that. And also recognizing that different users will need different interfaces with the information. So as an engineer, I probably want a very different type of interface with the information, or potentially at times I want a very different type of interface with the information than a strategic decision maker might require, who wants to understand implications of cutting the budget for a program or changing resource levels, etc., or changing potentially even the scope of the work. So it's about understanding the range of tools that we need for different purposes and for different users. And then the last stream, sort of major stream of the program, is the demonstration work. So this is about taking the technical work from the other two streams that I've just discussed and pushing them up against real life problems on the basis that we know that you can deliver something in a theoretical environment, push it into the real world, and it possibly doesn't work quite as you anticipated it would. And it's really important, clearly, that this does work in real life, in the real world, against real problems. Doing this also exposes other areas that we need to address. So, for example, legal considerations, commercial aspects, security again, trust, ethics, that human tool interface. So how do we get this so that this is as intuitive as possible, but also so that decision makers understand uncertainty and risk in modeling as well. So they're not assuming that because a model is showing something, that is necessarily the single answer. They need to understand uncertainty in that model. And also the cultural change that is going to have to happen as we drive this forward and as this becomes more commonplace. So we're doing demonstration work with the Global Centre for Rail Excellence. We're also working with the Rapid Capabilities Office in the Royal Air Force. But the big part of our demonstration work that you may have heard about is taking place on the Isle of Wight. Why the Isle of Wight? Well, it's obviously it's an island. We've got a lot of the stakeholders are very focused just around providing services on the island, although of course there are other stakeholders that provide services more widely. It allows us to avoid the problems of scope creep because we've got a bounded area. And we've also got some really passionate people on the island who are really interested in wanting to get engaged in this project, and that has been. They've been very, very supportive about the idea of us trialling this on the sort of microcosm of the UK. And then we can then start to look at how we scale that more broadly across the UK. What we did was we started with a quick demonstrator. This allowed us to set ourselves a baseline. We did that at the end of last financial year. So we really understood what the cost of doing that work was and what the value that we got back. So I always refer to it as our quick and dirty demonstrator, but it really was about what's the quickest, easiest, dirtiest thing that we can do, that we can say, right, that's probably the bare minimum. And then we can build on that. So again, every time we increase complexity, we can understand what it costs us to add that complexity and what's the additional value back for stakeholders. So what we did at the end of last financial year, as I said, was we took information from multiple open sources. These related to transport, fuel, energy, water, comms and medical facilities on the island. We used Royal Engineers expertise to be able to look at the interconnectivity between those different sectors and between the different assets. So we looked at parent-child relationships. I say we, it wasn't done by me. But, you know, I depend on you, you depend on me. And then to assess the vulnerability and criticality of the different assets and the systems on the island. We pulled that information in, and then we and that information was then, all of that information was then taken, and it was mapped onto the integration architecture, onto the information exchange standard 4, and then we were able to create an application that sat on top of that with something called Paralog, that enabled us to start visualizing the information that had been gathered and exposing that sort of criticality and vulnerability that had been assessed. Just highlight a couple of key aspects because it's been quite useful for us both. It's been very, very helpful in terms of getting stakeholder engagement on the island, but it's also been very useful in terms of starting to show the power of some of this, and that's very helpful when we're talking to policymakers in this space as well, and also to start exploring the capability of the tools that we're developing. So what it's enabled us to do is to show that we can bring together different types of data. So we can bring together structured data and we can bring together unstructured data into a single platform. We're doing that this year, this financial year. This is very much more focused around static data, but we will starting to bring in dynamic data. So understand how we can get dynamic data flowing into this system as well. And it's not about, and it's also about understanding what information we need to bring in. We don't need to bring everything in and map it onto the information exchange standard. We need to start understanding what needs to be mapped and what doesn't. We've also we're able to link out with external data sources in this as well. So it's not, as I said, it's not about necessarily bringing everything in and putting it into IES. It's about saying, where are people doing good work? Where are people doing good work that we can basically pull in and managing data very well elsewhere? How can we link up with that and making sure that we can actually get to those, link up with those other data sources or tools in this type of platform. And then what we've also done is I think this is really helpful just in terms of, we talk about the interconnectivity of assets, and I think this starts to expose just actually how powerful visualization tools are. And we're not even talking digital twin at the moment with this. This is these are very basic visualization tools, but actually they're still really powerful. And I think this is why we can show that you can drive real value even by enhancing the tools that we've got at the moment. So we talk about the interconnectivity of assets, and this shows just how interconnected things are. So those particular utilities that I talked about on the island. And that's, again, as I said, it's been really helpful in terms of just getting stakeholder engagement, because people really start to look and understand just how interconnected and interdependent things are. So going forward, this year, what we're looking at, we've got a couple of streams that we're looking at. So emergency planning and response, ultimately looking at asset resilience, so both in terms of asset loss and ultimately asset degradation. So this is really focused, well, we're putting this against particular use cases, which in this case is flooding in a particular area of the island. It's what we're really trying to look at, although we're making it real with that use case, is about how can we use these tools to improve how we manage assets and decision making about them. So really exploring that aspect. And the second stream is around energy. So how can we use these tools? We think we can use these tools to deliver better policy and to ensure that people are better able to understand implications of decisions and how they lead to the delivery of a policy or otherwise, and how they potentially cause tensions between different policies. So we're using an energy use case, which actually is around retrofitting of homes, to start looking at how do we balance demands of different policies, and how do decisions, as I say, impact on delivery of a policy by a certain time. I alluded to earlier, just really in conclusion about collaboration. It is really important that we are collaborating as much as possible in this programme, and very much collaborating across a number of different departments within government. As I said, we're also within the department as well, but also with the likes of DCMS, with DFT, with DCMS, CDDO, DSA, ONS, etc., etc. Lots of really positive engagement and collaboration, which has been fantastic, as well as, you know, UKRI, as I said, who are doing research in this area, as well as organisations outside government. So a lot of collaboration, and anybody that is interested in getting involved in the programme, very happy to talk to anybody about getting involved in the work that's going on, and to look at how you can support that and get involved. And then really just finally, just to emphasise key principles of the programme, these are very, very important to Barry and myself in terms of how we drive the programme forward. So honesty, I mentioned this earlier, being really honest about where we are currently, what we've achieved, what we haven't achieved yet, and just how much work has to be done. So no smoke and mirrors, absolute honesty. Everything we develop has to be lift, shift and drop. If I can't pick it up, plug other data in, and it just works, we're not going to get this to scale, and to scale to the UK, and it's not going to be adoptable. So everything again is, and it goes back to that point about no smoke and mirrors, everything lift, shift and drop. It's no good as developing a bespoke solution just for the Isle of Wight data on the Isle of Wight. We have to be able to say what we develop with the tools are to be able to take them, and they just work elsewhere with other data sources. And all of this has to be scalable, has to be able to be scaled to the size of something of the UK, and it has to be adoptable. So low barrier to adoption and high value. That's it. Thank you very much indeed.
No, thank you, Alex. That was an incredible amount of information. So thank you for that. And bang on time as well. So I'm very impressed with both aspects. There are some questions that have come through. What I'll do is I will give you two at once now. They are quite different, but just so we can get through these questions and go forward. And they're two quite different ones. The first one from Paul is, you mentioned a few times there about policymakers and your reference to them. So the question is roughly, how much does this initiative at the moment rely on current government policy as opposed to what future policies and priorities might be, which is a good question. And then the other one from Basil is about potentially the relationship to IFC from part of this. And I'm guessing, without prompting what the answer would be, is I go back to your comment about the brownfield data into a greenfield site. I'm wondering whether you see IFC more on the brownfield side or as part of the extension to the ontology as part of the greenfield aspect. But I think those two are the more prevalent ones I'm sticking out for now.
Okay, right, so the policy one, that's really hard. Who knows what policy is going to be going forward? I think all we can do is to say, yes, it is. At the moment, we've had support of previous ministers on this work and Secretary of State. It got through comprehensive spending review. I think our job as a programme is really to show the ongoing value of this. So this is why we have to really show, we can't disappear into a corner somewhere and deliver all this and say, well, don't worry, great things are going to happen in 10 years' time. We have to be able to show continual improvement and continual value, because that's actually ultimately the only way that we're going to be able to sustain policyholders' interest in this programme, for them to understand how this contributes to their objectives. So that's on that one. The ISC question, yes, so we've obviously got a lot of work that's going on within sectors at the moment. What our job is to look at is how do we interface with that? So it's not about chucking out anything that already exists. It's about saying, what do we need to be able to pull? What sort of different data formats do we need to be able to bring in and make sure that we can integrate them with the work that we're doing as well. So there is work going on in that space, and not so much at the moment, but certainly will be going forward in the programme, will be really key as to how we start looking at all of these different data sources, the formats they're in at the moment, and how do we integrate with that.
No, that's brilliant. Thank you very much. And we'll see a bit of you later when we have our security discussion panel. But thank you for now, and we'll see you in a bit. And what I think is really useful there as a half segue is that we obviously heard about the Isle of Wight pilot, and what I'm very interested in seeing now is also very pleased these showcases from early adopters who are doing some quite exciting things in the cyber physical space. So we've now got some project showcases. So what I'll introduce first Nathan Marsh, Chief Digital Officer even at Turner & Townsend. So Nathan, if you'd like to come on and take us through some exciting work you guys are doing, I think that would be great. Thank you.
Thanks very much, Dan. You can hear me okay?
I can, yes.
Brilliant. Okay, hi everyone. So I'm Nathan, the CDO here at Turner & Townsend. Today we're going to talk about 5 things. Let me just make sure these work. We're going to look at the understand the purpose of the conversation, talk about trends and insights, look at case studies, and then finish on summary and questions. It was great to hear the last definition of cyber physical infrastructure, or the last 2. We're going to offer one as well, which I think is probably helpful to get different perspectives. We'll then look at some trends in the cyber physical environment, what we see from a big infrastructure and real estate program delivery perspective as those programs bring together the physical and the digital. We'll then touch on some of the benefits of getting this right and when we can optimize the best possible designed and delivered and operated physical asset and the best possible digital complement to it as well, and see what that coming together can deliver in terms of benefits. We've then got a perspective which is largely experiential, looking at some of the prerequisites for success, and then we can talk about some case studies. We've got 3 great case studies as well. Just in terms of Turner & Townsend, we're a professional services company that focuses very much on real estate and infrastructure. We're growing rapidly, and I think that's probably a great endorsement of how exciting our sector is. We have about 500 digital consultants worldwide. About half of those are based in the UK. In terms of the trends and insights that we see in the market, a working definition, welcomes some debate on this. We do see that connectivity, convergence, and integration are a big trend in cyber physical infrastructure, not just the coming together of cyber and physical, but also the working together and the weaving together of these 2 versions of the same thing. We see that it consists of increasingly connected assets and ecosystems right down the supply chain, whether they be machine-to-machine trading capabilities at tier 3, tier 4. But we do see them integrating the physical and digital, not just for the sake of it, but to really focus on performance improvement, to take an integrated and programmatic approach, an organized approach to managing data, systems, and interfaces. And there are many of those across some of the more complex major infrastructure and real estate programs that we see. And also the domino that can probably knock them all over, which is making sure that both the cyber and the physical infrastructure element and asset is robust, secure, resilient, and allows the asset to be operated predominantly in the physical space, but also with its digital twin. And just some interesting stats, I think, as we're collecting our thoughts for this conversation. So some examples there of getting cyber and physical infrastructure right. BMW improved their performance of across software packages by 30%. Rolls-Royce removing 22,000 tons of carbon by deploying machine learning, so getting a digital capability within a manufacturing site. And then Siemens on the vaccination and ventilation program, increasing productivity from 10 to 1,500 in 4 weeks by modeling and modeling and modeling. So some really practical examples of organizations that get the bringing together of physical and digital right. We see some big trends in the market. We see that BIM and digital twins and Internet of Things are growing in complexity and use. So we need to consider data governance, cyber and physical security, setting standards, data policies, how they apply to how data is gathered, stored, processed, and disposed of. These are all crucial. The data sets are complex, but the integration is even more complex. So the bringing together of these things needs strong governance, whether that's at the building or city level, or at the network level across 5G. So it's really important to understand that where each of these brings complexity in its physical or its digital sense, bringing them together and keeping them together is a challenge. We also see the increasing scrutiny and focus and frankly digital literacy in the investor community, which we welcome. So investors, whether it's government funding through Treasury, different schemes, whether that be European or overseas capital, or indeed the institutional capital, are getting increasingly digital literate and understanding that the assets that they invest in, when digitally managed, increase in value. When come accompanied with a digital twin, can increase in value even more. So you can see that getting this right not just protects the physical asset and the digital asset and keeps them working together to improve performance, but it also means that they're adding structural and economic value to a balance sheet, whether it's a program or an enterprise balance sheet. So there's a strong economic case for getting this right. Some of the benefits of getting this right are that data can be shared easily across both the physical and the digital. The ability to make complex, rapid, and accurate decisions using integrated data sets. It gives us what the kind of military and intelligence services call context. So then 10 data sets together can give you far much more information if they're well organized and well spread and placed across the physical and digital assets, that give a much richer picture, and that can help better quality decision making. It also helps pace. If we get this right, we can get the digital twin or the BIM model, providing us data to make rapid decision making, particularly in the built environment, and respond to some changes which inevitably happen on long-term programs. It also supports collaboration. We mentioned earlier governance, but the importance of data sharing protocols, who can have access to, see, manipulate, use, and share what level of data, what type of data, when, why, for what commercial return. That's really important to get right in complex multi-vendor, multi-partner ecosystem programs. It also helps us to get the importance of delivering environmental value and social value benefits through programs. If we can embed those through the supply chain contracts, but also then use the data sharing to try and make that happen and make it easier to happen. We see an integrated framework for resilience and robustness being absolutely the right approach, such that these security systems are secure and robust by design. We're also very keen to look at the net zero component and get the right level of data and evidence to demonstrate adherence to net zero commitments within a program or an enterprise. And again, if you've got a robust digital version of your physical asset, particularly in operation and maintenance, then providing carbon reduction readings, whether they be embedded carbon or emissions, is a very powerful case for getting cyber physical infrastructure right. We think there are 6 fundamentals that really stand out when we're asked by clients, okay, Nathan, so that's all very interesting and very compelling. How do we actually start to get this right and what do we need to put in place? So we think 6 things are important. Interoperability. Interoperability and openness are really critical for maximising the societal and environmental potential of cyber physical systems. The ability to move between parameters and partners reduces the likelihood of some monopolies within programs and enterprises. It also, by its very nature, starts to create infrastructure assets and programs that share by default in a controlled manner, of course. On security, developing trustworthy systems will require consideration and consolidation of existing new and potential ethical and equality challenges. Greater sharing of information can also carry risks on privacy, commercial advantage, national security, democratic rights. So we've really got to think big, as well as some of the more technical but important programmatic risks and enterprise risks of getting security properly considered. On connectivity, for cyber physical systems to realise their full potential and for the model to deliver its full benefits, suitable mechanisms and commercial incentives for sharing data must be in place. The level of connectivity across programs like Lower Thames Crossing, New Hospital Programme, Hinkley Point C, for example, are absolutely profound. And the complexity is made easier, not harder, with sound and robust connectivity between the physical and the digital, and also using things like a digital twin of a schedule or of a supply ecosystem to work out connectivities, interfaces, and interdependencies. On sustainability, the adoption of sustainability and mandating of it into asset performance and program performance is welcome. Businesses and bodies must be able to adapt and trust cyber physical systems and how they use and drive information to get the right outcomes. On resilience, smart connected systems can respond rapidly to changes in need, from reconfigurable manufacturing systems to adapting to new output requirements. Fleets of smart machines must be resilient by default and also be robust enough to handle the volume and complexity of data that flows through their networks. We're aware of level 4 and level 5 autonomous vehicle trials generating the same amount of data in a complex 15-minute trial scenario as a steady state period of running of the Large Hadron Collider. The message there really is that to get these systems really resilient from a protection perspective, but also robust from a data complexity and data handling perspective. And then lastly, on innovation, innovation is needed in a wide range of industries. Accelerating the rate of innovation and evolution of good practice is going to be crucial in getting the best long-term returns from the successful convergence of cyber physical infrastructure. We also see some pretty cool industry approaches. Clients tend, when they get this right, to start with a strong strategy. They then tend to focus on getting set up for success, that strategic patience in the middle, which is often leapfrogged. There's a lot of work on strategy and business case, and then they focus straight on delivery. So it's important to get that set up before you head on to deliver the program. When we see organizations get this right when they focus on maturity assessments, a vision and strategy, have sound project management, look at controls, and also then think about the infrastructure asset management ultimately. In terms of case studies that really bring these to life, we picked 3. And you can see, I hope, that they relate to the 6 elements in our kind of prerequisites. But Heathrow really have made great inroads in getting this right. They've automated PMO reporting across a complex portfolio. That enables them to intuitively not just work out performance across the portfolio, but also start to predict using modeling in a digital version of the physical environment. And obviously an airport is a complex operating environment. This gives them real insights. They're constantly working around regulatory constraints, which we understand, and safety constraints. So it's a safe environment in which to try different models. With the use of automation, robotic process automation and IA, it's sped up decision making, increased the fidelity and accuracy of the data. and really has provided some powerful benefits, a 40% reduction in the reporting effort, because the work, the legwork, is done in that digital environment. Looking at high speed 2, creating a digital twin of the asset and of the schedule is a really compelling example of the physical and digital coming together, and cyber and physical being done right. Having a clear vision for digital asset information, again, think back to that autonomous vehicle and Large Hadron Collider example, the amount, the extent, the complexity and the sensitivity of HS2 data, still many years ahead before the asset opens, is already profound. So managing a digital environment for that data to be structured, shared, used, support design, planning, routing considerations is really important. The conceptual information model is secure by design, interoperable and open only as needed. And again, it's also given some great collaboration between different ecosystems, supporting detailed areas of intervention to drive down carbon, and brings together a unified vision and strategy for the HS2 digital twin, which the supply chain can lock into. We also see great progress in government as well, particularly across some of the more progressive real estate initiatives. Applying BIM and information management and a data strategy to existing assets is quite complex. Some of the government sites we work on and we've seen best practices in are profoundly complex and sensitive as well. Managing the design and implementation of highly secure areas, and in some cases covert areas with physical elements, Faraday cages, airlocks, etc., are really complex to get right. So the physical environment is extremely constrained. The digital environment is highly sensitive. Bringing the two together is extremely complex. But when it's done, integrated its applications, systems, data, bring together the full rich picture of the asset performance. And it's great to see our government driving this progress ahead and this method ahead across, at this stage, 13 major new buildings. So as we bring it together, it's really important for us, I think, when we look at cyber physical, to focus on the integration between the digital and the physical with a focus on performance improvement. That's the measure of success. Has life in the program or the enterprise got better? Secondly, taking an integrated and programmatic approach so that we're organized, structured, and ideally there are no surprises. And then lastly, providing a level of resilience and robustness and assurance to demonstrate to stakeholders, supply chain partners, that this coming together of the cyber and the physical aspects of an infrastructure asset or real estate asset is a safe and wise thing to do. And it will start, if we get that right, we'll start to drive out benefits of interoperability so we can collaborate better together. Security goes up, connectivity is made a little easier because it's controlled, sustainability targets are met or exceeded, the resilience and robustness and the muscle within these cyber and physical elements of the asset is improved, and innovation and evolution can start to operate by default. So look, thank you very much for listening. I'll be delighted to take any questions and look forward to the conversation.
No, that's fantastic. Thank you very much, Nathan. And some questions are coming through, but as I think talked about earlier, what we'll do is we'll hear from Anna first, and then we'll deal with the questions at the end between the three of us. So what I'll do now is I'll quickly pass over to Anna Whitmore, who will go through some of the interesting case studies and stuff that they're doing over at Mott MacDonald. So Anna, thank you for joining us, and over to you.
Thanks, Dan. So I'm going to focus on mainly just two case studies I've got today of cyber physical systems that we've developed. They're both kind of focused on a water sector example. I thought before I jump into these case studies, I'll just spend a couple of minutes seeing a bit of context around why I think this stuff is really important. So we have some massive challenges that are facing infrastructure at the moment. I think most people in the industry are aware of these, but they're becoming increasingly public. So things like the impact of climate change, assets which have been chronically underinvested in, and population growth are all really pressing challenges at the moment. And although these issues aren't new, they are kind of growing in their scale and size and complexity and do require a kind of new way of thinking to try and tackle them. I think it's important to appreciate that these challenges aren't things that can be solved by a single individual or solution or organization. They require a real systems approach to be able to come up with a solution. On a slightly more positive note, there's also a real massive opportunity at the moment around the increasing digitization that we're seeing. We're generating more data than ever before. I think the latest stat shows that there's over 5 times more IoT devices in the world than there are people right now. And although like we're seeing a lot of asset owners and organizations begin to treat data as an asset, there's still a massive divide between the amount of data that's getting collected and how it's actually being used to improve decision making. I think that really just goes to show that data is just one part of the answer to get better outcomes. We also need the right expertise, the right tools, technology, and analytics to be able to actually generate insights and ultimately improve decision making. I think this is really where cyber physical infrastructure comes in. It has the potential to provide the building blocks and the connections so that we can extract insights from this data, improve decision making, and ultimately generate better outcomes. So the 2 use cases which I'm focusing on today are both examples of, I've said digital twins. I don't think we need to go into the definition again, and you can call it a digital model, a digital shadow, a digital twin. I'll show you the case studies and you can decide how you want to define them. But I guess this is the point being that this is just kind of one potential component within cyber physical infrastructure. It could be something like robotics or AI as well, but this is what I'm focusing on for these 2 examples. And broadly speaking, digital twins, as we know, are all about capturing data from the physical asset, deriving kind of near real-time or right-time insights using different tools like advanced analytics, and then using that to inform decisions made on the asset to make better decisions and ultimately improve the asset performance and outcomes. So the first kind of example that I wanted to talk through today is a system we developed to address water scarcity for the southeast of England. So the UK southeast currently has a population of about 19 million people, and it's facing real massive pressures around water supply due to a combination of population growth and climate change. I think the current forecast for 2100 is that there is going to be a 28% increase in water demand for that region, which is the equivalent of 1.7 billion litres of water per day. So this scale, this is like one of those massive challenges that I'm talking about, and it's not something that could be addressed by a single organisation or single company. To start to try and tackle this challenge, Water Resources Southeast, or WRSE, was formed, and that's kind of formed of 6 different water companies with the remit to develop a plan across 37 resource zones. So to be able to develop this plan, they need to analyse over 2,000 different options across these water companies. So an option could be something like a pipe transfer, a reservoir, a desalination plant, and each of those different options had about 80 different metrics, so things like the cost, the carbon, the social capital, environmental factors. Also, they needed to account for doing sensitivity analysis, looking at different climate scenarios, population scenarios, and things like demand over time. So historically, each water company would develop a plan by themselves for their own region using kind of traditional file-based approaches. But Water Resources Southeast recognised the complexity that was presented by the volume of data, the number of interfaces, the amount of different data flows, and that it required a different approach. So we used our Mott MacDonald Moata platform to develop a central data landing platform, or DLP, which has underpinned the entire planning process. It's essentially enabled the automatic capture and integration of data across all these different organizations, facilitated data flows between teams and also different optimization engines, and surfaced all the results through like simple dashboards that are easy to understand and visualize. It's also provided a really detailed level of auditability. So every decision that's being made about the plan, they can pinpoint where this data has come from, what company, who's checked it, and what assumptions were made at the time of making that decision, which I think is really important for something that needs to go through so much public consultation. by bringing together all this information on all the different water company assets and options and climate scenarios, Water Resources Southeast were able to make a decision looking at a systems level, not an asset, which is ultimately resulting in a better outcome for the Southeast. I guess a key enabler for building the system was actually the people. So the water companies that were willing to integrate their data into a secure central platform, teams willing to collaborate to get together to identify the best solution. And that was just as important as the DLP that we built as well. So we were able to actually help with this super complex, high impact program, making it manageable through having this cyber physical system, which is enabling a kind of first of its kind system engineering approach to help build a more resilient Southeast. So that first example was looking at kind of a systems level use case. I just wanted to drill down now and show one of our examples that's looking more at an asset level. So this was an example of a digital twin that we built for a particular wastewater treatment works. It was built actually in Auckland, New Zealand, originally to help with commissioning of a new reactor. So being able to do things like scenario analysis and help with making decisions around how to optimize commissioning. But since then, we spent quite a bit of time working with the team to look at different challenges that they're having and trying to use this system to tackle those challenges. So just bringing it back to that kind of key components of the digital twin, we had data coming in from SCADA, the kind of flow monitoring systems, lab results coming in on water quality, had information about the operations and maintenance regimes, information around the kind of climate, things like weather predictions. We then had the insights piece, which is the interesting part when we bring in the kind of the engineers. So that's using advanced analytics to be able to get insights out of all this data. So we had a biological model, was actually partnering with a third party called BioWin to be able to run a model in real time in the background. We had machine learning models that could do things like predict flow into the plant based on weather. We had a range of other kind of data analysis tools that we use to do things like data cleaning in real time. We're able to use our Moana platform to bring all that data together, apply these analytics in near real time, and then visualize it all through kind of easy to use mapping and dashboarding, so that whether you're an engineer looking at something on a more detailed view or an operator who just needed some key information, you could look at that and understand what interventions you should be making on the plant to then be able to, you know, reduce cost, reduce carbon, improve outcomes overall. There were two kind of aspects that we were focusing on this year. The first one was all around how can we reduce the operational cost and carbon of the site. So at the moment, the company often looked at the cost and carbon in spreadsheets. They maybe did it once or twice a year. It was really hard for them to say, okay, we think we want to tackle this issue. We want to try something different and actually see if it works. So the challenge that we had was, could we come up with a way to identify hotspots in near real time, be able to try different control strategies and actually be able to view trends and see if it was working. So to be able to build out a solution like this, we started by looking at what data is available. We need things like chemical consumption, energy consumption, solids production, process emissions. So looking at what data was available on the site. And then we needed to kind of look at the analytics that was going to be able to tell us this information. So that's when it came back down to the modeling aspect. If there was something we couldn't measure, calculations to do things like determine chemical consumption based on tank levels. And the outcome of it was essentially, this is the key kind of deliverable that's being used at the moment, which is a dashboard that shows the operators or engineers for each different process unit. They can see the cost per day, the CO2 equivalent per day. They can then identify where are the hotspots, start to come up with control strategies focused on those areas, and then be able to review the trends over time to see if those are actually, if the intervention is actually making a positive outcome. Something that was really interesting that came out of this is a bit of a tangent, but they realized how high their process emissions were, actually realizing that that was contributing almost 70% of the operational carbon as a business was coming from process emissions. And I think there's a bit of a global trend with water at the moment now, realizing that process emissions are not well understood and actually quite hard to measure as well. So part of this project, we actually went out and put kind of gas and liquid into our measurements on the reactors. we then had a real-time model running as well, and we were able to kind of compare actual captured data, a real-time model, and that gave us so much more insight into the mechanisms that create process emissions and different potential things about how we could actually try and reduce them. So that was like a really interesting outcome that came out of this piece of work. The other thing that we looked at on this plant was how we could improve asset data quality. All of these cyber physical systems are only valuable if there's quality data that are going into them. And one of the issues I have at wastewater treatment sites, at least, is that instrumentation can be quite unreliable, often fouling, especially when in wastewater. It's expensive. You know, you're paying over $100,000 for certain instruments, and also requires a lot of maintenance. So we built out soft sensors, so like a virtual sensor that could do a number of different things to kind of help with improving that data quality. So there's a few different ways you can use soft sensors. The first one is to validate, so build out a sensor of an existing instrument to then be able to kind of do things like detect if it's drifting or broken. You can supplement data, so things like lab results, we can only get them every 5 days. You can build a soft sensor out to kind of increase the frequency of that information, or kind of the top level is potentially actually start replacing instrumentation and reducing the amount of lab sampling, which obviously reduces labor requirements and reduces operating cost. At the site, we focused on building them out for soft sensors. So we used a range of different modeling techniques to develop sensors for solids, flow, ammonia, dissolved oxygen, and then actually set out alarms that went to the operator to say, we think there's been a drift event that's happened, go out and check the probe. And that we actually had really positive results on that. They were able to, I guess the benefits is instead of going out and doing maintenance every 2 weeks, they just could go out when there was actually an issue, and overall the quality of those instrumentation, the data improved because they were knowing as soon as something had gone wrong. Bringing it back to kind of the kind of main concept around cyber physical infrastructure, I think these 2 projects I've talked through are a really interesting examples, or I think they're interesting, of where we've built centralized systems and they're really improving decision making, but for a specific system or asset. I think where you can start to connect these different cyber physical systems is where you can really create a step change in the potential benefits that can be realized. So for example, this first benefit that I was talking about is, you know, we can build a digital twin of a treatment plant and we can optimize carbon for that one treatment works, which is great. But then if we could start to connect, and I think Nathan was kind of talking about this as well, to, you know, not just the treatment works, but also networks and pump stations, that's when you can start to actually say, you know, we were going to build a new tank at a treatment works. Now we have a better view of a whole system. We realize there's more capacity in the network, and we can actually identify a no-build solution and reduce having embodied carbon. And then I guess if you kind of build on that again, if you start to get that connection between a water digital twin and an energy digital twin, you can say, well, let's just time our energy consumption with when we know that it's maximum percentage renewables in an electricity grid. So you can see with each new connection that you're able to make, there's new information available that can support your decision making and generate those wider benefits. So I think this is where cyber physical infrastructure is really exciting, because it does have the potential to enable connectivity between all these systems and unlock that wider value. So again, I've been focusing on kind of digital twin examples today, but these could be any type of cyber physical infrastructure. It could be a component like AI or robotics or any other kind of synthetic environment. But being able to transition from centralized to connected distributed systems is when we can start to unlock these really wider benefits. I think cyber physical infrastructure is hopefully going to be able to enable this transition, providing the right kind of building blocks, frameworks, and ways of working to enable this connectivity. And this comes back to that kind of first point, is that these building blocks can help us actually use the data that we're generating to get new insights on infrastructure, make better decisions, and be able to tackle some of these really scary challenges that we're facing at the moment. I think this is the last slide for me, which is just as someone who's kind of working on projects in the weeds, the kind of things that I think we really need to kind of start to move towards these wider outcomes. So I think the first one is around access to quality data. So, you know, asset owners and operators being willing to provide us with data at the right frequency and actually treating data as an asset, improving its quality so that we can actually start to innovate and build these tools. The second way is all around having common ways of working, which it sounds like Alex Luck is solving that problem. So that's great to know. But things like having secure data, like ways to transfer data, all these examples I've shown are just working on kind of point-to-point bespoke connections. But if there was more standardization around this, consistent data models, you'd just be able to move so much faster. And I think the last point is actually probably the most important one. So both of the examples I've talked about today were only possible because we had asset owners who are willing to share their data. We had technology providers who are willing to integrate their solutions and taking a more ecosystem approach. And we had teams that were willing to work together to kind of agree and implement new ways of working and be willing to change. So I think having people who are able to collaborate is really actually almost the most important point out of all of this. I think that is the last slide for me, so I'll hand back over to Dan.
Oh, brilliant, Anna. Thank you very much. And if you and Nathan could turn your cameras on, we'll just go through a couple of questions we received. So again, thank you everyone for the questions you are submitting. These are great. I think, Tristan, you are currently our top question asker, so congratulations to you for that. Let's see if anyone can beat you by the end of the session. But what I'll do is I seem to have one for each of you and one for both of you, which actually works out very well for me. So we'll see what else comes in. And I guess it's a question for Nathan, but I'm kind of triggered a bit by the bit towards the end of yours there, Anna, about collaboration. So we've had a question through, Nathan, about with HS2, you mentioned how with the digital twin bits and the digital assets you're developing, the supply chain were able to log in and access those bits and pieces. So I guess how much focus happens from a TNT side on supply chain integration and that kind of digital literacy bit to make sure that they're able to access and utilize those things?
I think the beauty behind that example is that the project is so big and so national and so long running that it gives all aspects of the supply chain the opportunity to respond to contract terms which can specify different levels of integration and interface with a digital twin of the schedule, some of the cost and commodity data, so the different components that go into building the asset, and then also into the physical asset itself once it's up and running. Although that's going to be more for things like the train operating companies and associated kind of commercial partners. But it's just a great example, I think, of a program, and there are more like it that are following its example, where it's really encouraging interlock with the supply chain, not just through kind of standard contracts, but getting digitally connected into the delivery of the program. It's really good to see.
No, that's fab. Thank you. And I'll try and flip flop as best as I can. I guess a question here, which I find personally quite interesting for myself, Anna, is that Alex talked about it a little earlier about the use of the digital visualizations to solve answers and things, and you brought that up as well in your presentation. So I guess in reality, how much is the data visualization bit almost one of the key parts of getting insight out of that data, as opposed to the models themselves, but that kind of transformation of it into something visual for people to see? And is that normally the way that it's conveyed back to clients and stuff at once?
I think it really depends on the audience. So if I come back to the examples, maybe the wastewater treatment part, the analytics was really important because that's what gave us insights and enabled us to actually predict performance on this plant. But those analytics were quite complex, and you needed kind of an expert process engineer to be able to do that piece of work. I think where the output of that is being able to present it in a way that operators can actually understand. So I think it depends. If you're a process engineer, you do want to be able to see that level of detail, and that is relevant to you. But most of the people using that information they need to just see something that's easy to understand, easy to consume, and that they can look at and get key pieces of information. So I think, yeah, visualization is important. I think a lot of the times we will develop different views depending on who the user is and kind of what level of technical expertise they have and what's relevant to them.
No, brilliant, thank you. And while I've got you, another quick one to come through, which might be one that you can answer quickly, which is one or two people have asked, what is a soft sensor? If you could just clarify what you mentioned using them, but what actually is a soft sensor?
So a soft sensor is, I'd call it maybe a virtual replica of something that is happening in the site. So for example, we developed a virtual sensor of a flow, which would be, you know, you'd have your real instrument, which would be measuring flow. You'd have a soft sensor alongside it, which is generated through a model or a calculation. You could also use a soft sensor to derive something that can't be measured. So if you wanted to calculate or have real-time sensor for something that you actually can't use an instrument or can't use a lab sample, that's when you could have a soft sensor running in the background as well. I'd also recommend Googling it. So I think there's just a nice Google definition that might be able to explain it a bit better than I can, but that's essentially how I'd describe it.
No, that's a great place to start. Thank you. And then, so the question I got for both of you, and I guess Nathan, we'll start with you for this one, is that it's Tristan's question, and I will pull bits out of it. But as mentioned in the presentations, obviously people are key to this process, which is great. And what we're looking for is, I guess I'll read this out here. To what extent is the absence of personal buy-in a barrier to trying to do these kind of cyber physical endeavors as part of it, and in particular asking the question in the broader context of climate, biodiversity, and supporting the UN sustainability goals. I guess part of that question might be, if I flip it on its head, is I guess what's the value creation that's taking place here? Because we're connecting the physical and digital together, and presumably it's not just a sum of its parts. There's a value add on here, and in particular, I think I saw in both your presentations those kind of outcome-based bits going beyond it. So I guess so with you, Nathan, really is what is that kind of value creation we're creating? The value creation that's taking place on these projects.
I certainly agree that it's people that get things done and willpower that gets things done. Contracts help. Contracts can be quite restrictive, but they're obviously vital and mission critical. That people will behave within a certain way, either to terms or principles within a contract. So they are and should be the most important part of the machine, if you like, of the system. In terms of value creation, I think it's useful to look at the value in data and the value from data. The value in data comes from how data is used to improve performance in a program, to manage an asset better using data more effectively. So you start to look at performance issues when you get the value in data. The value from data then is really around its investability. So we speak a lot with particularly institutional investors and private equity firms, which will run a ratings listing on the value of a digital asset. It's certainly not £0, and it might not be £100 million, but the value extracted in data can be held on a balance sheet, and then capital or debt facilities can be drawn against it. That's really interesting move, particularly in government-led infrastructure programs, where we're starting to see on project balance sheets and on enterprise balance sheets in more progressive organizations where data is held as an asset class because it's got purpose and it's adding productivity to the asset. So a building on its own might be worth X. A building which is smart enabled and managed well is worth X plus. The digital twin of that building, because that's the digital blueprint, it has the performance management data, security data, that doesn't exist in the physical world, it exists in the digital world, and that can be held on a balance sheet. Another kind of trend that springs to mind, we had our first moment of this last month, which is where clients ask us to value a real estate or infrastructure asset in the metaverse. So they want a conventional valuation on a digital asset, which is really unusual, and it's probably going to start to cause a bit of a trend in the market, I imagine. So that's my view on how you can get value creation by the convergence, the appropriate convergence of physical and digital.
No, that's great. Thank you. Anna, how about from your side and on behalf of Mott's?
I don't know how I can follow up the answer from Nathan. It was pretty good. I think I probably take it from a more project-based point of view, which is being able to kind of enable data flows between different assets or systems is where you can derive a lot of value, and you can create those opportunities for wider benefits to be realized. So I think that kind of goes back to having those examples of the more kind of assets, systems, people that you can connect, the more opportunity you have to make better decisions that are going to, you know, result in better economic and environmental outcomes.
No, fair. And I guess on the subject of those connections, obviously what you're trying to do is integrate those people, technologies, stakeholders, processes, products and things together. So in Mott's first, I guess, to flip around, what are some of the issues you're seeing with that integration? I think you mentioned some of them in your deck, like consistent data structures and data languages, but what are the rubs you often find in trying to connect these things together?
Definitely data quality, which I guess is why I kind of focused on it quite a lot. I think there's, you know, a lot of the ideas we have around interesting things we can do during project delivery and design around BIM, when we start to try and trial different certain optimizations or new tools, a lot of the time it's the data in the model and the underlying data that's missing or just not of appropriate quality. Same thing when we get data from the client, the quality of it, you can spend so much time just trying to understand and improve that as the first hurdle.
Oh, brilliant, thank you. And Nathan, how about yourself? Challenges for integration?
I think it's just a complexity. So whether it's a real estate project, infra project, particularly on the big mega programs, but even more conventional, you know, easier to manage projects are getting increasingly complex. We are getting increasingly well tooled up though and skilled up to manage the complexity. But if you think about, I know, the concept of a digital first project or a digital first program, the first thing that goes down after the economic case will be the technology or systems blueprint. And that will start to then provide some sort of common environment where you can see all the different elements that have to talk to each other. And then you lay in, for example, the schedule, the costs, the components, commodities, milestones, etc. I guess what we're saying is taking that digital first approach is a great way to handle the increased complexity. And although these projects are getting more complex, if we take the right approach, they actually become more straightforward to manage. But if you try and manage a big real estate or infra project or program using kind of conventional tools and spreadsheets, the complexity within the program, the commodities in the supply chain, social value data, environmental data, evidencing it, regulatory adherence, it's just too complex. So I think the integration issue is more about managing the complexity and understanding where the integrations and interfaces lie, rather than just throwing a project management manual at it.
No, great, thank you. And then I've got one more for you, and then as a both as a warning for the next panel session, because we might come into it a little early, as well as to ramble a bit so that you can collect your thoughts for this question. I think when we heard from Alex and Jacob, I think one of the things that came up quite often were use cases, and that idea of actually trying to solve outcomes for those you're working with. I guess in this instance it'll be for your clients / customers as part of this process, and I guess just a bit of insight around how you respectively look at whether you look at use cases and how important they are, and this idea of trying to achieve outcomes from that way. And as I'm asking this, 2 questions are quickly coming through, so we might have another question afterwards, but if you can tell me a bit about how important use cases are, and I guess what we'll do is, Anna, we can maybe start with you first around the way that you work and its relationship to use cases.
So I guess we've spent a lot of time and effort developing our kind of technology platform, Moada, over the past kind of 10 years, and it has been predominantly led by client challenges. I think, everything that we do, we're continually coming back and making sure that it's actually solving a client challenge, providing benefits. So I think that kind of underpins everything that we do. I guess as well, every time we start a project, we do usually try and spend like an initial kind of shape stage, which is defining what the problem is, making sure that there's a really clear set of requirements, and we're not just coming along with a technology solution for the sake of it. I think that that's like absolutely key to every single project that we do.
Oh, brilliant, thank you. And Nathan?
Yeah, I think Anna's absolutely spot on. You know, think big but start small. Understand what the use case of an entire successful program or asset post delivery or handover could be, but then really start with quite tangible, pragmatic changes and improvements that you can make, or indeed a day in the life of, or a use case, an example which is quite tangible, and get that right, and then just scale it. And the measure of success is going to be improved performance, something you can measure. You know, we brought RPA in to automate order to cash. Well, brilliant. So do you now have total adherence to the prompt payment code? You're spotting and avoiding duplicate payments. Those are the performance measures which really define true success, rather than just throwing in a technology solution for the sake of it.
Yeah, I'd just add to that. I think it's beneficial for us as consultants as well to make sure there's really well-defined KPIs and metrics at the end, so that we can both get to the end of a project and be able to measure it, and both have confidence that there's value being delivered. So I think that's, again, really just backing up, important to have those well-defined metrics. Stop it from, yeah.
No, that's brilliant. Thank you both. And then just the final one to lead off is that if some people wanted to find out more about some of these projects or some of the exciting stuff that you guys respectively are working on, is there anywhere in particular you might direct them to? I mean, it's probably easy to say your respective websites, but is there somewhere slightly more focused people could go to see some of the exciting work you're doing in these digital spaces? And I guess, Nathan, I'll start with you.
Thanks, Dan. I mean, yeah, websites, fine, LinkedIn, but actually IPA, the Infrastructure Projects Authority, Project 13, ICE, some of the industry bodies are really good at showcasing exemplars. So I think, I'd probably go there first, because then you tend to get not just great examples of where we're seeing this done right and done wrong and learning from those, but they're also fairly agnostic as well. If that helps.
No, that's brilliant. Thank you. And from yourself, Anna?
Yeah, I think I put a link in the chat to the Moana Marketplace, and I think that has quite a lot of information around the different kind of products and deployments and type of work that we're involved in. So it's always a good place to have a browse as well.
No, that's brilliant. Thank you. I'll ask the team to share the MOTMAC link further, and then Nathan, in between, if you've got a Turner & Townsend link you want us to share out as well, we'll get that shared out as we go. But what I'll do is I will call the Q&A to a close there, and if anything else comes through, we'll put that as part of the follow-on Q&A session afterwards. So just want to say thank you very much to Nathan March and Anna Whitmore for joining us to show off some of the work that they're doing in Turner & Townsend and Mott MacDonald respectively. Thank you very much for joining today. I hope you have a great rest of your day, and I guess God bless.
Thanks, Dan.
Thanks, Dan. Cheers, Anna. Bye-bye.
Thank you. So what we're going to do now is I'll move on to our final session of the day, which is going to be our cyber physical security panel. So what we have is we'll have Alex back, who you saw earlier, being joined by David Mudd, the Assurance Global Head here at the BSI, focusing on digital trust, and then Bridget Kenyon, who's the Chief Information Officer with SSCL. So I guess if you guys are about, if you could turn your cameras on and come join, that would be fantastic. Brilliant, there you are. I was worried as we were starting that a tad early, I might not have had you, but I can see you and you're all smiling, which is fantastic. So what I will do is I will stop talking, and Alex, I will let you carry on from there. Thank you all very much, and I will join at the end. Thank you.
Lovely, thank you very much, Dan. I just wonder, actually, as Bridget and David, you haven't spoken yet, would you give a bit of an introduction to who you are and what you do?
Yep, I'll start if that's okay. So I'm actually the Chief Information Security Officer for SSCL, Shared Services Connected Limited, which is basically a back office provider to government, defence and police services, part owned by the government. My background, well, I started off with a physics degree and ran out of ideas what to do with it, so I kind of fell into engineering and then fell sideways again into information security before it was really a thing. So that was back in 2000. And I discovered it was fascinating. I loved it, and I had very little IT knowledge. So I promptly vacated the scene for a year or two and got some experience doing network engineering and systems administration, and I got an MCSE and all your kind of basic frills, so I could feel like I could know whereof I spoke. Since then, I have really majored in information security with the occasional sort of side channel in IT management. I set up information security management systems for Warwick University. I developed the UCL ISMS. I've been most recently, before my current role, I was CISO at Thales DIS for the EMEA region. So yeah, I sort of have a mixture of consultancy and in-house security roles really. So PCI DSS, and in my spare time I also participate in the BSI standards development community. So I've just finished, I think, being editor for the most recent revision for ISO 27001, and I've also been lead editor for ISO 27013 and 14. That's me.
Thank you very much, Bridget. Just to say, we're having a few problems with your mic. I don't think it's just me, so I don't know whether there's something in front, but we lost you. Well, you went very sort of faint, so just to be aware of that. Okay, David, pass to you.
Thanks, Alex. Hi, everybody. I'm David Mudd, Global Head for Digital Trust Assurance within BSI. So that's really looking at the domains of digital governance and risk, cybersecurity, privacy, data, artificial intelligence, and then the digital supply chain, and really through kind of training, assessment, testing, certification. And Bridget's already mentioned ISO 27001, the information management system, just gone through a very important global update there. And that's obviously a very key part of what I'm looking at. My background, I trained as an electronics engineer with the BBC. I then served as an engineering officer in the RAF, doing lots of fancy electronic warfare stuff we thought was really cool 25, 30 years ago, but you've got more fancy stuff in your phones now than we were dealing with then. It was a very good grounding. So BBC, RAF, MOD, delivering some secure IT systems there, then working with various SMEs before joining BSI. So a whole string of TLAs, 3-letter acronyms there, getting me to where I am today. So really looking forward to the discussion. Really interesting seeing security being mentioned a few times today, and it's really, for me, brought out as well, I think, some of the key themes around collaboration and people, and from a security perspective, the challenges that the need for collaboration and people engagement can bring. So really looking forward to the discussion.
Great, thank you very much. Both fascinating backgrounds into what you're doing now, which is brilliant. So just to start, really, I mean, we've obviously heard a little bit about what people see the opportunities of cyber physical infrastructure being. Just to start with you, Bridget, what do you think the biggest opportunities are in this space?
Opportunities for who exactly?
Oh well, pick whoever you like.
I head to all of these things with the opportunities for the bad guys. That's why I'm asking.
Oh well, yes. Well, opportunities for the good guys and then opportunities for the bad guys.
Okay, yeah, opportunities for the good guys. My background, as I've said, is in a mixture of IT and security, and a lot of things that we try to do and manage and understand on the IT side include physical infrastructure and IT infrastructure. And half the time you want to explain why you need to do something, or what your business case is, or where your problems are. And it all comes back to data. It all comes back to be able to see how things have changed in the past and be able to predict the future. And the number of times where I've had to sort of throw together a frantic PowerPoint with some scratchy little Excel stuff hiding behind it. And then you go to the meeting And people look at well, apparently quite polished diagram that you've created. They ask maybe 3 questions and the whole thing falls apart like a house of cards, because you haven't got your supporting data. You can't go and look at what it looks like today. You have no longitudinal information at all. So being able to provide that stuff based on reality, not on some poor soul that spent 4 hours walking around all of the different servers, downloading their processor utilization, or walking around all the different server rooms and finding out what their temperatures are at the hottest day of the year. Or, there's a million different things that I can see as direct usefulness. And then you flip into this whole digital twin thing, which is definitely new for me. And you're not just reading out the data and being able to provide information back. You're going, okay, let's change something and see what happens. So in the perfect world, you're in a meeting with top management and they say, well, maybe we could just change the, we're trying to save the environment. Let's just up the temperature of all our server rooms by 2 degrees, because that's going to save us X money. And they can go and find out what X money is in this perfect world. They can see that immediately because they can see how much they're being charged for electricity. And they can divide it into groups. They can look at the group labeled server room and see how much they're being charged over the last year. And they can do that right now. They don't have to wait 4 hours or even till the next quarterly meeting, which is quite often what you have to do. And they can go, right, okay, we'll up it by 2 degrees. And they've got 20 minutes to see what happens. Yeah. So you can actually start doing things in a much more adaptive and immediate fashion, where the people who are genuinely interested in something and have some very high level questions can see what happens if they make the decisions, and they have the information ready and available from the real world, not it's my best guess. I hate standing in front of senior execs and going, it's my best guess. I mean, with security, you don't really have much choice. For the bad guys, I mean, what a wonderful opportunity to be able to increase somebody's server room temperature by 10 degrees, or turning off the air conditioning system altogether. Turn off an air conditioning system, you've got 15 minutes and everything fails. And if you're super lucky, you melt things. I've actually seen that happen. Or even better, if you could do some really horrible, subtle things. You can meddle with the data that's being used for the model, and then people will make decisions based on that data, and they will make the changes to the system that then breaks it. So if you get into that loop, you can turn it from a virtuous cycle into a vicious cycle. And people will be running around for days, maybe even months, trying to find out what went wrong. You could actually destabilize an organization completely by cherry picking certain individuals, finding out what systems they have access to, and damaging those systems using their user accounts. And then you can actually pull people off an organization and push new people in. If you perhaps want to replace the CIO, you can discredit the CIO by getting into the systems, and the new person turns up that you own. You can make everything go back to the way it should be, and they look like they're amazing, and they can start feeding you data. So, I can make up a million scenarios here.
Yeah, it's quite scary, really. Yes. David, what about you?
So when we're looking at the opportunity, first and foremost, I think there are 2 levels to it. In the short term, the biggest gains that I can see around things like moving to a predictive maintenance model, kind of really a bit of what Bridget was saying there as well. So we've seen that. I think Rolls-Royce was mentioned earlier, and for me, jet engines, I think, were one of the first where a jet engine is kind of sold by the flying hour rather than as a capital asset, and therefore by having a predictive maintenance schedule on something as flight safety critical as a jet engine, rather than preventative, i.e. just changing and fixing things whether they need to be changed or not, or even worse, corrective, you're waiting for it to fail and then having to rush an emergency part out there. To be able to predict and manage maintenance in a controlled way is very efficient from the maintenance perspective, and obviously great then from saving costs overall, and very, very effective. And that becomes, I think, when we go back to, I think, as was mentioned before, some of the low-hanging fruit of pick something, think big but start small. The predictive maintenance is the easy way in, I would say. And then when we're looking, where we really want to get to is that point of insight. And for me, there are 2 dimensions to that. By this mass connectivity, the one is to be able to know where everything is at any one moment in time in a way that we never knew before, and the instantaneous status of every asset. And then, as we've also seen, it's that long-term trends and be able to analyze those long-term trends in a way that was never done before. And that moves really into another whole dimension of insight. Now, again, as Bridget said, everything that can be used for good can be used for bad. So when we're looking at putting these fantastically cost-effective platforms in cloud services and all this kind of thing, you know, as we've seen now, you no longer, just as you can have your whole of your CRM and the whole of your business management as a platform and buy it as a service, you can buy ransomware as a service. You don't even need to create it yourself. So what we've seen as with that rapid acceleration of digital transformation, and we've heard today about that dramatic escalation amounts of data that's available, we've also seen the industrialization of cybercrime. So Bridget's talked through some very specific, detailed, technical, social engineering and combinations that are very, like what you'd see as a sophisticated attack. But we've also seen just that now bulk mass attack now. Typically a new device, there are maybe every minute or so, there's another IoT device connected somewhere, every few seconds. It takes less than 5 minutes for a new device connected to be attacked in an automated fashion. So we have to see that industrialization and digital transformation we've been through positively, exactly the same thing is happening within the cyberspace. And it's largely driven at the moment, the most attacks are actually monetary driven rather than say motivated by sort of state and political objectives. The vast majority of it at the moment is down to ransomware and purely looking to get money.
It's interesting because you both, I think you mentioned the trust issue in it as well. So it's not just necessarily somebody going in and doing something malicious and that being very obvious, but it's actually how do we trust the data. And we heard from Anna's presentation when she was talking about, you know, using that data to make decisions about when to go and carry out maintenance or intervention. That I think, and do you agree that's both that's as well as the sort of more malicious one is also can be just as disruptive.
To one point on that, we talk about security, we tend to dive in there with the confidentiality part, but it's confidentiality, integrity and availability, and that integrity piece is so important. And this is as well, I think we also tend to focus a lot on building a wall, and we think, you know, security is a lot more than just a wall. You know, we have to be looking at the whole from both looking at threats, future threats, as well as current threats, but then in particularly looking to detect anomalous behaviors throughout the whole ecosystem. Because most attacks, as Bridget's already hinted at, aren't a smash and grab. They can be in there very subtly, just changing data, taking data, just making subtle changes, sometimes for months. So that's another key point here is security is so much more than building a wall and looking at that end-to-end process, identify, protect, detect, respond, recover, as well as just building a wall is so key.
It's not just about changing the data. All you have to do is create a sufficient level of concern or doubt that data may have been changed. So if you can create that doubt, you don't even need to break into a system. You just have to convince people that it might have happened, and people will cease to trust the system and they will cease to engage with it. So yeah, so you can do something very much more subtle with much less actual technical clout. Yeah, the other thing that I remember noticing was the idea of secure by design and default. People love that. And David was just talking about the IoT situation where loads of IoT systems are going online, and frankly, everything gets attacked as soon as it goes online. So if you can control enough IoT systems, you have a free source of what they call computation, which you can use to what they call it Bitcoin mining. That's very handy. You can basically generate money from nothing, or more accurately, you can generate it from somebody else's electricity supply. But you can also use those systems to attack at other things. So the reason that it's so hard to deal with, the underlying, well, as I see it, the underlying problem is that a huge proportion of the systems we depend upon today, including IoT systems, but often the back-end servers, were built in a time of, shall I say, naive optimism? Yeah, I shall. Where everything was really a hobby. In fact, at the beginning, if you look through the Microsoft Windows terms and conditions, it said it was not intended for professional use. And some of the code that was written at that time and was in the system at that time still exists in that system in the current versions of Windows today. It's all like accreted around this center, and the center is a hobbyist system. So unless you fix the problem, which is at the middle, you are always going to be playing whack-a-mole. And the IoT systems are a good example of that. You constantly find vulnerabilities because the underlying architecture and design, coding design, was written quickly and with the idea of getting it to market, not with the idea of making it secure, and not with the idea of doing any kind of protective maintenance beyond about 2 years. So, you know, you put an IoT system online, it's maybe well looked after right now. All it is a ticking time bomb. You leave it until it's out of support. It's not going to stop working. No, it's just going to be far more useful to far more people that you don't know about. So it's a bit of a whack-a-mole. It's not something we can fix very efficiently today. All we can do, honestly, is admit that it's there and do what we can about it. There's a tendency to just say, you know, technology will fix the future. If we admit that technology has holes and we put that right at the beginning of our design process, so you don't do a proof of concept and then add security. You do your proof of concept including security, and you at least recognize the problems and decide whether they're something you need to worry about. That's the only way I can see to do this.
That's such an important point, the security by design, particularly with IoT, because, you know, with our standard ICT, there is a pedigree of security there, and generally speaking, there is the budget, which might be physical space, processor power, memory, communications bandwidth, to manage security. With IoT devices in particular, if security isn't designed in, there isn't that budget to add it on, and particularly when it's deployed out in the field remotely, that's it. It's a one shot and it's gone and we've blown it. So I think IoT in particular, and its importance, I think, to the cyber physical world is something we really need to call out here as a particular area of concern.
Yeah, and where do you stop saying something is a thing, and when does it become a computer? It's a complete continuum.
And also, most IoT producers tend to be the T, not the I, and are heavily dependent on their supply chain to bring that connectivity. And then how do they actually in control of what pieces of embedded firmware are in there and what open source code is in there, and how will their supply chain be able to manage the vulnerabilities? So when we're looking at the complexity of cyber physical systems, we've heard already that you've got all kinds of different products, all kinds of different systems, all kinds of different organizations, and therefore when I think it truly, we need to look at this holistically, in that they all connect, and those connections aren't necessarily apparent until you look at the whole thing. The connectivity also goes back through the supply chain. You're not buying a physical product or a platform, you're buying into that organization and the supply chain that provides it. So I think there's a lot more here around the organization, the people and the supply chain, as well as the digital physical asset itself that you're actually looking to integrate with.
Is it knowable though? Are we actually trying to, you know, are we trying to untie the Gordian knot? Do we have to say to ourselves at some point, there is a limit to what we can know about a system? I mean, you can do a perfectly understood and perfectly known system, but it is so horrifically expensive to achieve. They only really do it for like aircraft controllers. But
I absolutely agree with you.
This idea that we can understand something, even from a process and you know, technical level. And do we need to maybe let go of that?
I totally agree with you, and this is something I've just finished a world tour at the moment, going on around the updates to 27001, and in particular looking at threats around cloud. Ultimately, there is residual risk in some of these products, issues, paths we want to take, and it's understanding what that residual risk is once the mitigation is in place and the impact of that, and then looking at how else we can either accept or manage that. And I think that's the thing. We will never solve, from a technical perspective, every single risk here, but I think it's important to understand the context, the risk, and then look at what is their residual after we've mitigated what we can, and the impact of that. And is that a risk that the C-suite are prepared to take or not to move forward?
But then there is something that still fits, that still hides inside that, and that is the idea that you can understand a risk. There is a fundamental problem with how we're doing risk management at the moment, which is that we're pretending it's a science, and it's not. especially in the cyberspace. For things like actuarial risk, there's buckets of data, so we can do statistical analysis. But for information security and cyber risk, we're actually making up numbers most of the time or relying on our own personal experience, because nobody will talk to each other about incidents. And also the threat landscape, the world in which we live, is changing. I mean, we're having this conversation about cyber physical infrastructure. You know, we're at we're somewhere in the Gartner hype curve of a very new, exciting thing. But the very nature of the fact that we are doing new stuff means that the risk, we don't know what it is until we just go for it and see what happens. We know human nature, and we know the way that humans work, and we know the sort of mistakes that we make. So that's kind of something you can start with. But what the problems can, I mean, you couldn't even imagine ransomware before it was invented, and now suddenly everybody knows the term. So we've got a situation where we have known unknowns, and we have a methodology for risk management which is almost a pseudoscience. You know, this times this, and you've got your color codes, and then some people have these complex algorithms they use, and then they add in this and they add in that, and there's a factor for the other, and all you're doing is hiding behind a smoke screen of what looks like something quite technical and quite precise and numerical, when in fact you're just going, this is what it was like yesterday, and so I'm going to guess it's more or less the same today. So we're actually relying on I'd say experts, people who have a ton of experience and competency, and hoping that they can predict the future. And that's the scary bit.
Yeah, it is quite scary. And I think almost in a true example of cybersecurity and the dangers of it, Alex's internet has crashed. So no doubt someone has gone in and through some sort of hostile kind of acts has cut her off, so she can't moderate the session.
Sabotage.
Yeah, well, precisely. The very thing we're talking about. But to pull it back around as well, so I feel like if I just didn't jump in, you two would talk for an hour. It would be really interesting, which is fantastic. And I think we need a fireside chat in the future. But to pull it back now, to relate to some stuff you talked about, and not that I don't disagree with anything you've been talking about, does this highlight why it's so important to think about not cybersecurity, but cyber physical security as a subtlety here? Because what we're talking about is these risks, but is the potential risk now that actually, if you focus on one and not the other, it then creates the point of weakness, or the kind of the exposure point that can happen there. And I remember once reading an article about how someone managed to get into, say, I think it was Google's system in Australia by going through their VMS. So by having a building maintenance system that was actually connected into their main, in network, it wasn't password protected, or they had the classic admin username password style system, and they managed to get into the system via the building maintenance system, which effectively, for the sake of today, is a cyber physical system. So I guess just from yourselves, and maybe David, we'll start with you. That idea of cyber physical security and what needs to be considered holistically, what are your thoughts on that? And welcome back.
Yeah, I mean, there's the legendary one from quite a few years back about it sounds like something from a movie, where the casino in Vegas, the details of the high rollers and were stolen allegedly through a hack that got into the overall data system through the fish tank. There was a smart thermostat and it was hacked through. Now, again, there you've got to say, you're not necessarily blaming the manufacturer of the thermostat for the fish tank. You've got to look at who put that architecture together that said such sensitive data and everything was all connected and open. So I think absolutely understanding what you have, what's connected to what, and where the key areas of sensitivity and risk are, and then having an appropriate pragmatic strategy. I think it's impossible to say here's one security strategy I'm going to implement across the board. We've got to look at what's pragmatic, that's based on where the most sensitive data, where the most potential physical risks are, and having something that's appropriate, particularly if, as we've seen from what Alex was saying earlier, if we're going to really get the benefit here, we need to be able to open up and collaborate. And then having things like zero trust policies and this kind of thing when it comes to access to data will help, absolutely. But for that collaboration to take effect, we need to make sure that the critical areas are protected suitably, and then wherever possible on that continuum between completely secure and completely open, that we are selecting the right point on that continuum for that particular element of the system, because there's no one simple, oh, we'll just lock down everything and make it secure, because then nothing will work.
Yeah, security via actually removing the entire business. Yeah. Not totally popular, I've noticed. One thing you can do is divide and conquer. So pick out the stuff you really super care about, and then pick out the stuff that's frankly going to be a bit smelly in a year or so, because it can't be looked after the way you'd really like to look after it, and then making sure the two are as far away from each other as possible. I mean, you can subdivide further. You can start saying, okay, we're going to have a pool of God knows what in that corner, which is all our legacy stuff, and we'll make damn sure nobody else can get to it because it's awful and horrible. But then how do you do any kind of collaboration? How do you have a connectivity situation? I mean, there are technical solutions to it, but the trick is realizing you need a technical solution, because it will work, but it will not be secure. And being able to make the decision, okay, yes, we need to connect these systems, or rather we need to exchange this information. And for that, this system contains some information, this other system contains some other information about a physical world element. And we're going to make sure that when they talk to each other, we keep an eye on what they're saying. So if one of them goes a bit sideways, it doesn't take the other one with it, to overly simplify. With physical and cyber and security, I think there's probably 2 points that immediately come to mind on the specific subject of physical security. And one is that within the 27001 framework, the phrase that is used is information security, which includes physical aspects and physical security that can affect the security of information. So cyber physical intrinsically applies to information. We're talking here, underneath everything else, we're talking about information being transferred relating to physical elements that in the real world that we can see and touch and, maybe fly if it's a drone. The other thing is, the more you get cyber and physical together, the more it feels like science fiction's come alive. I keep having flashbacks to things like way back when there was a film called The Lawnmower Man about like virtual reality, and then it started breaking into the real world. And it feels a bit like that sometimes, that we've got like cyberspace, and it's starting to mirror the real world in places. And I wonder how far that's going to go. Not a security thing, it's just my brain.
Well, no, it's good. There's that bit of art imitates life and life imitates art, kind of conversely with, I'm sure I remember reading somewhere that, a lot of the mobile phone, flip phone ideas were actually from, Star Trek communicator style science fiction. It's people imagine what they want. I mean, one of the things you talked about there, Bridget, a few times, which I think is quite interesting, is that when you effectively get various data sets and then how they might relate or interoperate between them. And I guess one of the things that I saw Jacob talking about is the fact that we'll be collecting information from different sectors. So it's not just information about, say, construction and the built environment. There's agriculture stuff, there's healthcare stuff, there's lots of stuff from other sectors. And something else I remember reading about a while ago was the accidental associations you can make when you start to cross compare these data sets.
Yeah.
Yes,
yeah,
and
you can find out. Yeah, for example, you can see whether somebody's home or not by working out what their thermostat. And even better, I worked out. I had a smart water meter added. It was compulsory. Everybody's had it in the town, and I just realised that is the best way to find out if someone's home, because their heating system can be set to go on and go off wherever, but they can't automatically set their taps to go on and off. So if you really want to know if someone's home, you hack their water meter.
No, exactly. And there was a similar one I remember. I think it was, I'll get all the details wrong, but I'll say it was New York, it was Uber, it was releasing, I think, trip start and end places, and people could use Instagram with that to then backwards work out where celebrities started their journeys from, and as well as how much they were tipping people, so you could find out who the cheapskates were. But I think to pull this into this context here, if we are starting to amalgamate data from healthcare, which has a lot of sensitive personal data. You have sensitive assets, and all these different things. Where are there's probably the interesting areas where some of this rub could happen? I guess, David, I'll start with you on this. In that, where are the dangerous areas, and we'll try and or maybe areas where there's the best opportunity to correct, because I also like to flip risks are always opportunities, as we've said in this way. So what are the biggest risks to the good guys, and what are the really good opportunities to stop the baddies, I guess, David?
So you mentioned healthcare, and that tends to be the most sensitive area. If you look at where, and also where most of the bad guys focus on right now, the healthcare sector has been ripe for ransomware attacks. So as we've already just said, you can infer personal information from non-personal data, and it is possible to that you're handling data that you might not think this might not be personally identifiable information. However, personally identifiable information could be derived from that raw data. So once we get into personally identifiable information, very rightly, you're into some legal territory here around privacy laws. So I think that's one area we need to be very mindful of. Healthcare is both the most sensitive, but also I think the most potential beneficial, important area. If we're going to look at how the kind of future smart cities, the whole smart community can most impact society, I would say bringing sustainable, affordable, effective healthcare and allowing vulnerable people to maintain independence has got to be one of the best outcomes and one of the most valuable and early target areas here for cyber physical, for smart cities. But with that comes a lot of risk around, in particular, the healthcare data and maintaining that sensitivity of data when it is such a prime target right now. Now, the reasons why it's such a prime target: one, you've got very, very sensitive data, about the most sensitive you can get. Secondly, there tends to be that, we've already seen, certainly in the UK, a lot of legacy IT. You've got non-IT professionals in very awkward roles where they're having to manage a lot of sensitive data, maybe without the skills, training and support to do that, and therefore it's become such a ripe target. And what we also have seen, as Bridget referred to earlier, is if you start to lose trust in that system, it won't get used. So there's also within the healthcare system now, I think quite understandably, there's a big digital trust issue which we need to overcome to really start to build that digital healthcare opportunity to be something that's really effective. So I'd say that area is by far, I think, the biggest opportunity for societal impact right the way across the board globally, and it comes with its own set of challenges.
Yeah, mind if I chip in?
Yeah, of course.
Yeah, with regard to personal data and the sort of a continuum from personal through to potentially identifiable, through to what they call pseudonymized, through to completely anonymous. And if you map out the usability and usefulness of health data, the more useful it gets, the closer it gets to being fully identifiable. Because, you know, somebody in the world was a bit ill is about as anonymous as you can get. And like my second cousin twice removed might have been a little bit dodgy. That's fairly identifiable. That's definitely potentially identifiable. And you say, I myself had condition X yesterday. That's completely identifiable. And it, you know, that's the sort of thing that a doctor needs to hear to treat you, because it's detailed, it's identifiable, it's precise, and you couldn't go in and say a friend of mine has got a condition, or even describe the condition in detail to get meaningful medical advice. So that also applies to medical research. One of the things I like to use when I'm thinking about this, and I'm not a data protection expert, but it's a phrase that I love because it helps sort of ground me when I'm thinking about whether something is going to need reporting or discussing with the data protection people. No surprises. If the data subject is fully aware of exactly what you're going to do with the information, it should not be surprising and they should be okay with it, except in limited circumstances where you have another legal requirement. But even so, the data subject should still be aware of it. There shouldn't be a surprise if they learn the whole thing start to finish. In terms of the legacy IT side of things, there's also, and I fully agree on that, but I was just thinking about the privacy, and one of the biggest problems is that there is no single definition even for the word privacy that is used globally. The privacy ISO standards made a conscious decision not to define the word privacy, simply because it has so many different and very strongly held definitions in different jurisdictions across the world. Even the concept of who owns your personal data has dramatically different interpretations. In America, you don't own your personal data. In Europe and the UK, you do, and you cannot give away that ownership. So as soon as you get into the land of personal data, yeah, you can say it's the cloud, it's cyber, well, it's physical as well. But even cyber is physical. Every piece of data that we own or that we use is physically located somewhere. There's no magical cloud. There's electrons running through wires or superconductors or semiconductors or whatever, sitting in a rack somewhere on someone's desk. There is always a physical location. And where there is a physical location, there are a set of laws related to that geographical location which apply to that data. And that is really interesting when you start thinking about doing things globally and connecting things together, because if you start moving data between physical jurisdictions, legal jurisdictions, you get a whole load more headaches.
And just building on that, I'd say that if there's anything out there that's a blocker without an easy or any kind of clear, obvious solution to it, I think that transfer of data between jurisdictions is something that we only see as increasing in its complexity at the moment. What's very interesting, we're seeing quite a few organizations now moving data and people from China to, say, Singapore. And that's because China itself has brought its own privacy laws in that are now potentially in some areas directly in conflict with areas of GDPR in Europe. So even if an organization wants to comply, if they've got data from one jurisdiction and they're holding it in another, then they're going to be basically in breach of one of those two jurisdictions. So it becomes very, very difficult. So when we are looking at that that global perspective, I think the continual fragmentation of privacy law is one of the big obstacles right now.
No, interesting, and it makes me think of a couple of things. I think the one is that when I ever speak to Neil Thompson from Atkins about a few things, he always talks how interesting the built environment is, because you're always forced to have that connection with the land, that physical connection to geography, which causes a lot of our problems, which is why we can't do a lot of manufacturing stuff. And I think the analogy here is almost that way of, regardless of how cyber we get, there's always going to be that physical relation in that it needs to exist somewhere. As ephemeral as the cloud is, it's going to be located on something. And when you look at things like the facets of interoperability that appear in like EU policy and some of the international standards, one is transport, which is obviously physical servers, cables, etc., and the other is legal, in that sense of, as you're talking about, jurisdiction laws and rules, which is very interesting. I'm just conscious of time, and I've got a final cheeky question for you both. And because Alex is still having internet issues, it means I can ask the last question, and it can be my slightly controversial question, which I'll enjoy. We saw some of the project case studies from MOTS and TNT earlier, and my question to you very simply is: if you were a baddie and looking at those projects with their cyber physical elements to them, where might you think as a point of entry could be? There's not enough detail to know for sure, but where might you investigate as an initial point of entry to get access to information on those sorts of cyber physical projects? And that means then after they watch the presentation, they can go double check back at the office, but at the same time, I think it gives a realistic feel for us in terms of where are those typical weakness areas. I guess maybe we'll start with you, Bridget, in the sense of if someone has a project that might have these digital models, use these servers and things, where would you start looking first as a point of entry?
I'd start looking at the initial design phase, and I'd ideally get somebody involved in the team. Either add them in or pay them to provide me information on exactly what was being discussed. If possible, get them to, they should be one of the people in the basic design phase, because then they can be involved in setting up the security architecture, and I can make damn sure there's a way back in for me.
Very interesting, and I'll be honest, being part of the personnel was not the direction I thought the answer would take.
That's where I start. It's the easiest way, frankly, and it is what they call the social engineering way. And I mean, yeah, you can go techie, but if you can get in at the beginning, you don't need to go to that much trouble.
No, that's very interesting. Thank you. And same question to you, David.
I look at the supply chain. So if I look at the guys at the top, yep, they're totally on the case here. Security is the #1 thing. What are they services are they getting from whom, and who provides the easy backdoor in through the supply chain?
Yeah, that's a real nightmare for pretty much everybody, because we all have so many third-party suppliers, and there's only so much you can do to ensure they're doing what they're supposed to be doing.
No, that's fantastic. Thank you both. So in reality, the biggest weakness is people.
Yeah, that's true, Dan. But can I just say, I really want to change the narrative here. We need to get something like 85% of the breaches have a human element, but that means people are the biggest weapon. And what we've got to do is change that narrative from "you're all the weakness, you are the weakest link" to "we collaboratively are the ones who can change this story." And I think awareness and bringing that positive culture in is the way to challenge that back.
That's, yeah, exactly. And the nice thing is you don't have to replace all your servers to improve the 85% of your problem.
Well, yes, and as usual, as the consummate professional, you have turned my cheeky question into a valuable piece of learning, so thank you. Right, yeah, conscious of time, so I thank you both very much for that panel session. That was very interesting, and I am genuinely thinking about in the new year some form of security fireside chat where there's a visual of a roaring flame, but actually have these sort of discussions, because I do feel we could have you two on for 2-3 hours and without prompt actually have a really interesting conversation. So thank you very much for that. So I just want to say thank you very much to Bridget Kenyon and David Mudd for that. So thank you very much. And what I'll do is I will quickly do some final thoughts, sum up, and allow everyone back to their day promptly for 4:30. So just a few closing remarks. And I think, interestingly, I think David did well to steal that and say that actually, as opposed to thinking of people as the problem, we have a real opportunity through what we're doing to actually turn that into an opportunity, and that through upskilling, changing behavior, change management, that we actually can change what we are doing for the better in there. And interestingly for me, I think a theme that's come through has been thinking about the value that these digital innovations can bring. It came through at the start where Alex was talking about the value of what you get out of it versus the tech investment. And to be honest, something I've never thought about before is this idea of a temporary digital twin, where you might actually set it up for just a distinct period of time and then get rid of it. I always thought of them as being quite a permanent thing because of the investment to them, but I think it's exactly right, is that if the value would only be for those 6 to 9 months, why maintain it afterwards if it's no longer going to provide value? The idea that, through presentations like Nathan's, which focused very much on performance or progress improvements, it was very much that idea of we're looking at the outcomes as part of what we're doing. And I think Anna said it very right in that way of, because we have so many IoT devices, there are 5 times as many IoT devices than there are people. So actually the problem isn't access to data. There's too much data. There's too much information out there. But what we need to do is settle on what the use cases are, what the value is, and then how cyber physical infrastructure, things like robotics, digital twins, IoT, 5G, and these other aspects can then be invested in, turn that information and data into insight, which then provides that value, which I think has been very consistent all the way through, as well as this idea of how risks and opportunities can be flipped depending on who in the stakeholder kind of scale of it that you are. So I think that is all incredibly interesting, and I hope everyone watching has enjoyed that as well. So I think those are my closing remarks, and then what I'll just let you know then as a final point is that you can join us for more BSI webinars. So if you enjoyed some of the things that we're doing, we do monthly webinars typically as well that have a whole kind of raft of things we talk about, from fire safety, information management, modern methods of construction, and everything in between. And you can go on our website to find out about those. If you've joined today, hopefully you've heard about our other Built Environment Congress sessions. So we had one this morning on health, safety and well-being, and then tomorrow morning we've got quality and value, with tomorrow afternoon focusing on modern methods of construction. So please do join those, and of course you can always register for them, and then through filling in the feedback forms get access to the on-demand videos for them as well if you aren't able to join for the whole day. And I think look out for our 2023 event calendar, and in particular at the end of January we're going to focus on what are the priorities for British Standards for the next year, as well as maybe tease some of the webinars that you might see from us across 2023. So what I'll do there is I will say thank you very much to everyone who joined, and in particular to Alex, who both presented and then convened the panel session at the end. So thank you for that. I hope you found this valuable and useful, and hope you join us for a future session as well. Otherwise, have a great rest of your day. Thank you very much, and goodbye.
Thanks all.